I am Juan Carlos Franco, and I will be co-presenting with Matt Driscoll. We are both software engineers in the JavaScript API team, and we work mostly on widgets. Today's agenda will be covering two main sections, one of which is what can be customized from a widget perspective, and the second one is a few customization approaches along with some demos. And by customization approaches, we'll be talking about how to author a theme using Sass, where we will be able to change the styles such as color, sizing, font, etc. And also we'll be showing how to extend a widget view with TypeScript to alter the presentation and the functionality of a widget. For part one, we'll be talking about theming. So first off, why would you want to theme? Well, maybe you want to update the application to match your company's branding, or you would want to make sure that there is enough contrast with a theme or a particular set of colors alongside with the map. Another reason is if you have a specific type of user that requires, let's say, bigger buttons for them to press, you can do that by theming itself. So out of the box, the JavaScript API provides 10 themes that you can choose from. And the way you can use them in your applications is by adding a style sheet link with the appropriate URL pointing to a theme. And it follows this pattern where you will be providing the version along as the theme name. And we'll take a look at those next. So in this demo app, you can see it's a very simple mapping application. And I have here a select that will allow me to kind of browse through the different themes. And it's worth noting that all these themes apply to all of the API widgets. So if you see one that you like, you can just use it directly without having to do anything else. Now, before going into creating a custom theme for your application, let's talk about what technology we use to build these. In the API team, we use Sass to create our CSS. And if you're not familiar, this is a CSS preprocessor. And we use it alongside Node and Grunt to build all of our style sheets into themes. Now, Sass is a powerful scripting language that allows you to compile CSS. And it's also pretty neat because besides being modular, it helps you keep your code dry and makes theming easy because you can think of it as powered up CSS. It gives you access to features that you don't normally have with native CSS, such as variables, functions, utilities, along with some other features that makes it very powerful and easy to use. Here are the steps that we'll be taking to create our custom theme. First off, we're going to be using the ArcGIS CLI npm package. This package can be installed globally, and it allows you to easily create a mapping application as well as a custom theme for it, or even widgets. After installing, we're going to be using some of the styles subcommands to create, preview, and customize our own theme. After we're done, we're going to host and reference it in our demo. Let's take a look at the steps a little bit closer. So first off, we're going to be installing the CLI. Next, using the styles create subcommand, we can specify the theme's name, and afterwards, we can tell it to run a preview of our custom theme. Once in preview mode, we'll be able to make edits to the main Sass file, and we'll be able to see all of our changes live in the preview page that launched in the previous step. When we're done with our theme, we'll be able to eject it, which means that it will compile all the classes that we have and package it into a theme folder, which you would then reference in your application by adding a style sheet link and pointing it to your theme file. The reason we want to use this utility because we want to theme smart. We want to avoid adding any additional CSS selectors whenever possible, and instead relying on the existing Sass that we use in the API to your advantage. In the upcoming demo, we'll take a look at how the core file structure for the Sass themes are laid out. For now, we'll be focusing on three main files, which specify the color, the size, and the type of our theme. We define in the core files a set of variables, and we also specify that they can be overridden later by using the default keyword. Any value assigned to any of these variables later on will override the previous value. But wait, we are not done yet. A pretty cool thing that we can do with Sass is that by having or defining a few key variables, We're able to compute the value of supporting variables just by referencing one of the previously defined ones. So for example, here, we can specify the color of a hovered button just by darkening the button color by 10%. And this, of course, can be overwritten. If you want to learn more about this, we have a link in the SDK page covering styling in the API that you can reference later. And with that, let's get to our custom theme.
And this might seem familiar because it's based off of the theme switcher one that we showed before. And as you can see, it's just using the default theme. Everything is styled according to the light theme. And let's take a look at the code. And pretty simple. It's just using the CSS file as well as the API script. So let's take a look at our demo workspace, and we'll be working here in custom theme. And notice that we just have an index page. Pretty straightforward. Just a simple page bringing all the widgets that you see to my left. For the next part, I'll be using my command line, and I've already gone ahead and installed the ArcGIS CLI. So let's start creating our theme. You'll do that by using the styles create subcommand, and let's give it the name of DS21 demo. So this command will create, under the demo folder, a workspace directory that is specific to the CLI, and it'll also lay out a folder for a custom theme, in this case DS21 demo, with a main Sass file. And remember that we talked about the structure used by the JavaScript API themes. So if you take a look inside of the CLI's internal workspace, you can see that it's referencing the base files from the JavaScript API, and it has a few of the files that we covered, such as color, sizes, and type. And if you look into each one of these, you can get more details of how all these variables are set up. But for now, we'll just focus on a few for our demo. The next step that I mentioned is that we'll be running the preview subcommand to launch a special mode where it will compile the theme that we just created and launch a preview page that we can use to watch changes live as we're making updates to the main Sass file. Let's start making some changes. So first off, what I want to do is override some of the theme colors. You'll see here on the left how it immediately kicks in, and we can see our changes as we're making updates to the main Sass file. Next thing that I want to change is the type. Let's just modify the size. Right after that, I want to change the font. I feel like the buttons are a little bit small, but I can tweak the size, and we can see how that looks like. So this was a quick way to author a custom theme. So now that it's looking pretty much there, what I want to do is stop the preview process, clear my screen. And now that I'm done, I'm going to go ahead and eject this theme. And what this will do is it'll compile the styles and package them in a directory called DS21 demo, and it's going to include all the files that I need. So we can see here now that our DS21 demo now has all the resources that it's needed for the theme, as well as the compiled CSS file. So the last thing that we need to do is update our index page to use it. There you have it, our custom theme in action.
So let's recap what we learned. First off, we used the ArcGIS CLI for easy theming. Then we learned more about the theme structure used by the JS API's themes. Then we used this knowledge to provide overrides for some of the core values, and by doing that, we were able to create a custom theme. And now I'll hand it off to Matt for part 2.
Thanks, Franco. Let's talk about widget views now. So widgets are composed of both views and view models. And this is to separate the logic from the presentation of the widget, so that we just have all the logic in the view model, and the view is just responsible for presenting and rendering what we want to see. This allows the view model to be reusable and presented in different ways. You can totally replace the user interface if you want to, and makes it easier to integrate into a different framework of your choosing. Widgets are written in TypeScript, which is just type JavaScript. And a benefit of this is it allows us to write modern JavaScript. And because TypeScript is compiled, we can compile it to the browsers that we want to support. And TypeScript is supported in pretty much all of the major IDEs that support JavaScript and web. So more about views. Like I just mentioned, they present the widget. So this includes stuff like the DOM structure. And they use the view model APIs and they render that to the user interface. So they're pretty much there to define the DOM structure and the way that the widget looks. So all the view specific logic is going to reside here. And the views extend the widget base class, which is Esri Widgets widget. So this is the base class. And what it does is provides a consistent lifecycle and API for all of the widgets. So all of our widgets in the API extend this base class. So more about the lifecycle of the widget. There's a constructor, and this is what happens when the widget is first initialized. Then we have a post-initialize method, and this method is for setting anything up after it's already been constructed, but before the widget has rendered. Then we have the render method, and this is the main workhorse of the widget. So it defines the DOM structure and what's going to be displayed. So this is where you would set up all your elements, and this gets called anytime one of the properties of the widget changes. It'll re-render with those changes. There's also a when method that we've recently added, and this will get called after the first render. And then we have a destroy lifecycle method to remove any event handlers or do any cleanup that you need to do before your widget is destroyed. So let's talk about render. It defines the user interface and reacts to state changes or property changes. It uses JSX or virtual DOM and will re-render on property updates. So let's look at an example widget. This is the base map toggle. So if I go to the API reference in our documentation, you can go down to the section for widgets, and this is the base map toggle widget. And you'll see how it looks here, but we can also look at samples. So what this widget does is it allows you to change between two different base maps. So by default, this is a topographic base map, and then I can change to, I believe this is the aerial base map. So that's what that does. And then it'll show you how to do that code down here if you want to recreate the sample. But what I really want to point out is that the base map toggle and all of our widgets, you can get the widget view and see the source code, as well as the Sass styling for the base map toggle in all of our widgets. So here on GitHub, we have the source shared, so you can see all the dependencies, all the properties, and you can see the render method and how its structure is defined. And then you can also get all the styles that are used for that widget. So let's recap what we just learned about views. They are the face of the widget. They present the view model's logic. The view model and view separation allows easier framework integration and ability to customize the views without messing with the logic. And you can get the views and its styles on the API documentation page. Part 3, let's talk about extending a view. And why would you want to do this? Well, it allows it to be reusable and be in the same ecosystem. And how you would do it is you would extend Esri Widgets widget, which is the base class of widgets, and use the API for widget views. So that's like the render method and then the post initialize and stuff like that. So what we're going to do is we're going to extend a view and present the widget differently. We have a custom widget that we created called Layer FX, and we're going to take that widget and extend it and re-render it in a completely different way using Esri's design system's web components. And this is going to alter the presentation of the widget. So, little disclaimer, Esri's design system at this time isn't released. It's evolved from the calcite styling and is currently in beta. But it allows you to create beautiful, consistent apps a lot quicker. It uses web components, which are custom HTML tags that are encapsulated. And we can quickly build Esri branded, lightweight, and accessible web apps using these. So for example, here's an example using the custom calcite button component. And I can show that, how that looks. So here's a storybook showing the calcite button right here in the middle. I can zoom in to make it a little bigger. So this button is already styled for us, but there's also some properties that I can modify, such as an appearance, whether I want it to be clear or solid, or just a different outline. I can change things like the color, make it round, make it bigger, make it so it's loading, etc. And this is just using that simple tag for calcite button. So what we're going to do is we're going to look at this custom widget we created. It's inspired by this sample we have on the API documentation called Intro to Layer Effect. And what this sample is showing us is a layer of volcanoes with a layer bloom effect applied to it. And what I can do is I can modify that effect and achieve different looking render of the layer. And all this is doing is basically applying a string effect onto the layer, such as bloom with these different parameters here. So we've created this custom widget that does that, but also allows you to configure different effects besides just bloom. So here's the Layer FX widget. It has a little description in the title, and then it allows you to take a layer and apply different effects to it and tweak those effects. So I could apply some bloom, I can blur it, I can change the brightness, all the way down to like opacity and saturation. So we're going to be taking this widget that we've already created and we're going to completely change the look and feel of it by extending it. So before we get started with the demo, let's look at the Layer FX widget's interface. So the widget itself is the first interface on top here, and it extends Accessor. It allows the user to supply a layer to apply the effects to, and then it has a property that's read-only called effects right here, and it is a collection of layer effect, which is the interface below right here. And a collection is just a super array which allows you to watch changes of it and things like that. And then it also has the string of statements that gets applied to the layer.effect. And this is just a string. There's also the layer effect interface for each different effect type that we have. And so it has a property which a user can set enabled, and this is a Boolean. And by default, we have it set to false. And then an ID for each effect, so bloom, blur, etc. And then we have the values set for that effect, and this is an array of numbers. Some effects only have one value, and some effects have multiple values to them. And then we have a read-only property that is compiled depending on the ID type and the values. And this is going to basically be used for the units for that effect. Some effects have percentages they need, and some are pixels. So that's why that's there. And then a statement, which is compiled and read-only depending on the ID and the values. So if you want to learn more about how this widget was created, you can view our presentation for building your own widget. This is going to happen on Thursday, April 8th, 2021 at 10:15 a.m. It will also be available for viewing after. So with that, we can start with our demo and follow the steps. So let's explore the file structure of our demo. We're going to go into our source code, go into demos, start, index.html, and here's the basic HTML page we have created for our demo. Basically, we're just including the next version on the CDN of the JavaScript API. We have a file for our current LayerFX widget in its current design. So that's that. Then we have a main CSS file. It's just for positioning the map div. And then we've configured Dojo to find our demo files, either in the root directory of our demo or in the app folder. And then we're requiring our main file of the app. So that would be in app and then main. And in here, we're importing the map and the map view, a feature layer class, and our custom widget that we're going to be modifying. We set up our feature layer using unemployment data. We create our map and our view. And then we're creating our custom widget and adding it to the top right of our map view. We're also saving a global variable to the window so that we can access that widget via the console if we want to. And in our HTML file, we just have our map div placed here in the body. So if we want, we can look at the current LayerFX widget. This is what it looks like, the properties it has, such as layer, messages, view model, and how it's rendering in its current state, and some of the methods, private methods it has. And then if we look at our custom one that we're going to create, we can see it's importing the existing one, and then here it's just creating a new widget and extending the LayerFX, but it's not doing anything yet, and it's exporting it. We're also importing the TSX helper so we can write JSX with our widget, the subclass helper decorator to define our class, and the LayerFX widget. So cool. That's how our source code is set up. The first thing we're going to want to do is go and get Calcite and get it working in our page. So I can grab that from the README on the GitHub page. So the Calcite components in its current state, to add them, all you need to do is include the script tags here and the styles in your HTML page. So we're going to go in there, go into our HTML page, and we're going to paste those in. We're just going to put them in the head of our document. Cool. And we should be able to test this out just by adding a little bit of HTML to see if that Calcite button is working. So I'm just going to go into our body and I'm going to have a div that's positioned absolutely and use the Calcite button tag and see if it's getting styled correctly. So if I go back into our demo start position, yep, now I'm seeing a hello world button here, and this is using the Calcite components. Cool. So next what we're going to want to do is update the CSS of our widget. So right now it has its current design in CSS, and we're just going to delete all that and put a much simpler version of it, since we're using the components to style mostly. So we're just going to style the components just a little bit to give them some padding and margin. And then we'll be styling a code block later in the demo. And we just have some styling for paragraph tags. Cool. The next thing we're going to want to do is start up our TypeScript to watch our files for changes. So to do that, I'm going to do TypeScript compile -w. So it's going to start in watch mode. Anytime I modify the TypeScript file, it's going to recompile. So now we can start building our custom widget. And the first thing we're going to want to do is update its render methods. So by looking at the layer effects widget in its current state, I know how it's I basically know how it's rendering and its structure. So I can see it's starting out with a div, and it has a heading and a paragraph, and then it has another div which it renders a bunch of effects. And what it's using there is a bunch of field sets with the legend, and then it renders a HTML slider for each one of these. So I can see that here it's just using an input of type range. So what I want to do, since I know that information, I'm going to change it. And firstly, I'm going to override the render method. And instead of using the native elements there, I'm going to use a calcite block. And you can see that it needs to know about some of these classes, so I'm going to import that. So I'll go up here, import the CSS object from the resources file of our widget, and this just has the classes that I need to use and import. So it's just basically a lookup table. Cool, so it recompiled and it's not showing any errors now. If we go look at our widget in its current state, now we can see it has a slightly different design. It's got a darker background, but it's still using the field sets and the native HTML sliders. So we want to change that. So back into our code. Next thing we're going to want to do is update some of the other render methods, such as render effect. So we're going to add that here. So we're changing our render effect method to now use a calcite block section, which is a custom component. And anytime it emits this calcite block toggle section, it's going to call a private method update enabled custom. So this is the enabling, disabling the layer effect. But we need to create this private method so it knows what to do when that gets called. So we add a section for private methods and define the update enabled custom because it takes a custom event. So it looks at that target on the event and it gets the effect, and then it says, okay, do be enabled or disabled depending on what you are right now. So now we save and it's recompiled. Let's take a look at it. So now you see it's got these sections where I can enable and disable them, but it's still using the native HTML slider. So we'll work on changing that, but it is looking better. So what we want to do next is update some other methods to override them. We're going to update the method on the widget render effect value. And so this is going to render a different kind of slider once we're done with it. And you can see that it needs to know about this new private method right here. So we'll create that. Update value custom. So this is just going to take the event again, and it's going to set the value on the effect depending on the slider. And then we need to override how to render the slider and its label. So we're going to add another override for the render method. So we're going to override render effect slider label, and this is going to use, instead of a native HTML label, we're going to use a calcite label, and instead of the native HTML input slider, we're going to use a calcite slider and set the values on that. So now it should be completely different looking since we overrode the rendering methods. So recompiled, go back to the window, turn this on, and now we have different looking sliders to change the values of each effect, such as opacity, changing the hue of it. You can even do like a drop shadow. Cool. So that's working. So let's recap what we did. We extended a view and altered the presentation of it. We replaced render methods to create a totally different looking user interface. We altered the presentation of the extended widget by using Esri's design system components. And we updated private methods where necessary. So with that, I'm going to turn it back over to Franco, and he's going to talk about extending a view and altering behavior.
Thanks, Matt. Let's continue part 3 and show how we can extend a view and add behavior. In this demo, we'll be showing how to extend the layer effects widget that you just saw and add a little section to see the effects that are being applied. And we'll also use sortable.js to allow the reordering of effects. If we look at the current state of the layer effects widget, the customized one, you can see that as you apply different effects and keep scrolling, it's kind of hard to see which ones are active at the moment. So what we'll be doing is adding a little preview box that will help us see all of the effects that are being applied to this layer. We'll also be updating the UI to allow us to reorder each of the effects to produce a different result. For that last part, we'll be using sortable.js, and this is a JavaScript library that allows us to drag and drop items in a list. So this is what we're looking to add in our widget. Okay, so one thing to note is that this demo will pick up from what Matt showed you on how to customize the presentation of our layer effects widget. So having said that, let's go into the code and make the necessary updates to add our custom behavior. So let's continue extending the layer effects calcite widget to add our custom behavior. Just note that I have hidden away all of these sections that are duplicate or not relevant to this section, and we'll just be focusing on the render method. What I want to do is introduce a render method for that code preview. What I've added here is this method that will bring a calcite accordion with a single accordion item, where if we have any statements or effects applied, we will be displaying them. Otherwise, we will show a message to turn on an effect to see some code here. So now all I have to do is reference this method from the main render method. And I believe the perfect spot for that would be right below the effects. And now if I go back to my application, refresh, you can see if I scroll down, this is the new accordion section for our code preview. And if I click on it, since I don't have any effects enabled, I get the helpful message displayed here. But as soon as I start turning on a few of these, you'll see all of the layer effects being applied. All right, so for the next part, we'll be updating the widget to allow each of the effects to be reordered, because the order matters when they're applied to the layer for effects. So it seems like a good enhancement to allow this functionality be a part of the widget. So let's go ahead and do that. For this next part, remember that we'll be using sortable. So I want to add, as a first step, a variable that will hold a reference to this new sortable instance. And this is the instance that will manage all of the sorting behavior on the DOM for us. And the next thing that I want to take care of is, since we are creating a new sortable instance, we want to make sure that when the widget is destroyed, we properly clean up. And we'll do that by adding a destroy lifecycle method, where if we have created a sortable instance, we will destroy it. With that taken care of, we can move on to a private method that will take care of initializing the sortable. And what this does is if you pass it a DOM element and we have not initialized our sortable, we will go ahead and create a new one. And I'm configuring it so that any calcite block section is a draggable item. When a drag ends, I'm going to be updating the view model, which is the data model for our widget. And I'm going to reorder the effects based on the new order from the sorting action. Once I've done that, all I have to do is kick the sortable initialization in our main render method. And I'll be doing that by using the after create property on each element that allows me to access the DOM node for the calcite block. So whenever this calcite block is created, it's going to call the init sortable and initialize it for me. And now we can go back to our demo. And you can see, as before, I can toggle effects on and off. So first we have bloom and brightness, but now I can actually drag these. So now I should be seeing brightness and bloom. And there you go. So that was a quick and easy way to set up sorting inside of your widget. One thing that I forgot to mention is that we can reference sortable because I configured that in the application's main config. So here I'm just letting our app know that whenever I reference the sortable.js module, where to grab it from, and that's it. Everything else is pretty much the same as our previous demo. So let's continue. To recap, we extended an existing widget view, and by updating the render methods, we were able to add a small code preview block to see all the effects that are enabled. And we also used sortable.js to allow us to drag and reorder all of these effects. To conclude, in this session, we showed you how you can author a theme by using CSS. And we also learned how to extend a view of an existing widget to customize the look and feel of a widget, as well as to add custom behavior to it. Here are some additional resources that you might want to check out to improve your JavaScript widget development skills. And all these are links to the SDK page that you'll have access to from a repo in a link later on. And here are a few other sessions that you might be interested in. For questions, such as where can I find the slides in source, or if you want to submit your own question, here are a few bit.ly links that you might want to check out. That is it for our presentation, so thank you.
All right, thank you guys for watching our session. We got some great questions to answer. The first one, pretty obvious one, is where can we find the demo code and slides? And that one, we have a bit.ly link and we posted it in the Slido chat, highlighted the question as well. So check that out if you want to check out the apps or view the slides and stuff like that. With that, I'll get into the questions, and we'll start with Anthony. He asked, happy to see your theming repo get incorporated into the ArcGIS JavaScript client. Are there any plans to incorporate calcite theming as it gets rolled out further? Would be nice to have one coordinated place for modifying the JavaScript API and calcite components that are negless.
Sure, I can answer that. So if you're not familiar, previously there was another repo on my account that did the, it would fetch the styles used by the API, compile them, and give you like some CSS that you can just copy over for a custom theme. So all that has been moved over to the ArcGIS JS CLI tooling. And so the question about how to get that synchronized with calcite components, at this point, it's not really, I don't have an answer for that, but the goal would be to whatever sort of theming the API applies on the components, the tool would be able to support it. So the answer is yes, when the API starts using the calcite components and if it applies any sort of styling to it. The tooling will provide a way to tweak that as well.
Thanks, Franco. All right, next question. Using Dojo framework with the ArcGIS JavaScript API for X. That should be an easy answer, right?
Yes. As of a few releases now, I believe the API no longer uses Dojo for its dependencies at all. So no more Dojo.
No more Dojo. All right, the next question, Anonymous. Do you have suggestion on the best workflow for customizing widgets when working inside a framework like Angular, React, Vue, etc.?
That's a good question. In terms of customizing widgets from the API, I guess you could follow the patterns that we showed in this session. But in terms of how they integrate with React and Vue, that might be, I'm not really sure about that. I might suggest reaching out to the Ask Our Experts showcase chat in the web development team or channel. Maybe someone else can have a better idea of what that entails. But in terms of the widget views, as long as your framework allows you to define the view code with, as long as it gives you a way to customize that, it should be able to integrate well with our view models. So from that perspective, it should work. But yeah, maybe we'll get a better answer through the Ask Our Experts channel.
Perfect. All right, next question. Is it possible to rewatch this presentation?
I believe so.
Yeah, it should be available to watch. Yeah, you should be able to stream it after it's complete. So yeah, you can watch it and then grab the link to the slides and stuff like that. Okay, next question from David. What is the best approach to make text changes to labels, tooltips, and the like for internationalization and accessibility purposes?
Okay, so for that, we actually have some new documentation going out with 4.19 that will show you how you can customize all the different strings that come out of that are used by widgets, all the default text that are used by the widgets that get translated in the different locales. We'll have some documentation that shows you how you can customize that. So at 4.19, you can expect some more additional details on this, as well as some examples to accomplish this task.
Perfect. All right. Next question. Now that Sass theming is in the CLI, will there still be a delay between 4X releases and the theming tool becoming available, or will they be in sync?
Okay, so for that, the CLI received the styling custom theme support recently. So that means I'm still, like, the answer is I'm going to be the one that takes care of making sure that all the releases get in sync. So ideally, they should be in sync. It's just that if there is a little delay after there's a release, it should be minimal, but typically they should be in sync.
Cool. Perfect. Thanks, Franco. Any recommended resources for learning more about the view and view model architecture? Having a little trouble figuring out how to decide what bits go where.
Okay, for that is a good point to bring. We don't have any specific documentation on views and view models in the SDK, but I guess right now the best resource to access would be the widget view code that is on GitHub. There is I believe it's under the Esri org, under ArcGIS API. That project has all the view code unminified, so you can kind of see how the view models interact with the views. Outside of that, I guess the best answer I could give you is the reaching out in the Ask Our Experts channel to get a better idea. And also, I'll relay this message to the team because I think it's valuable to have that documentation somewhere.
Yeah, I think so too. Cool. Thanks, Franco. Anonymous question. What did you use to open, edit, and run the source code?
I believe for editing, I used IntelliJ, and you, Matt, used the Visual Studio Code, right?
Correct. Yes.
Okay.
And then we're just using a terminal to do the builds and TypeScript compiling.
Yes, and then for the theming part, it did use ArcGIS JS CLI that has all the tooling, and it'll spin up a preview, that preview page that updates automatically if you're running in that mode.
Yep. Cool. Another question, since I can already add custom components to the UI that could potentially interact with the map, without creating an official custom widget, what is the main advantage of creating a custom widget that's reusable and consistent with other Esri widgets?
I think for that, if you really want to develop a widget that follows the best practices that the JavaScript API team follows, you would do something similar to what we showed. And also, you can see more of this in the building your own widget session. But as a user, as a developer, you pretty much have flexibility on what you want to use as a UI component or a widget. So it could be anything, really, as long as it interacts with the DOM and the map.
Yeah, that's a good point. It's flexible, so you can use this widget development if you want to, or just apply custom DOM nodes if that's your thing. I guess one advantage of this is you could extend a widget easily using this method. Cool. Thanks, Franco. One user commented or asked a question. I noticed a dojo config.js in your project. Are you using Dojo?
No, I think if there is a dojo config, it's just a variable that we reference. It's not really picking up dojo. Like all that should be removed. Yeah.
Yep. Thanks, Franco. Another question about the slides. I created an announcement, and I think you should be able to see the slides in there. If not, when you rewatch the presentation, there's a bit.ly link to get the slides. So that should be it. And then another one, is there an example with multiple widgets that open and close?
Do we have an expand widget? Do you think that's what that is for?
Yeah, maybe they're looking for a sample customized widget for that. I don't know if there's one specifically for that, but it's looking at other widget examples. You should be able to come up with that pretty easily. So, anything else to add on that one, Franco?
No, I think that should cover it. An example that shows that.
All right. Just got another question. For information on GitHub, I can see the TXS files for widgets, but the view models seem to only be available as mini transpil.js files. Franco, do you know why?
Yes, we only unminify the view code. So the view model is the best place to see. I mean, from a consumer perspective, view models is just a module that you reference to get access to properties and methods, and all those should be docked in the API. Anything outside of that it is true, it is minified, but the views themselves show you how to work with the view model and interact with the DOM.
Yes, so the views are open source and you can see all the code for that and tweak them. The view models, you really shouldn't need to. That's just all logic stuff that you can use and extend to your benefit, but you shouldn't need to see that code unminified. Is that right?
Yes.
Cool. All right, another question. How localization should be done without Dojo? I guess how should localization be done without Dojo?
You have a few options. The API does have some modules to support with localization. I believe they're under Esri/intl. You'll find a suite of utilities to configure what we call a bundle, a message bundle that is basically a JSON file, yes. By default, we use a JSON file, but you can really author it to be whatever you want. And you can configure it so that when a widget loads, it'll go ahead and fetch that file, parse it out, and then the widget should just pick it up automatically. Besides that, if you're writing your own custom widget, it should be compatible with other INTL libraries or translation libraries. That should still work.
Perfect. Can these widgets be deployed in Web App Builder and Experience Builder?
That is a good question for the Web App Builder team.
Yeah.
From our perspective, like the widgets, all they need really is an HTML node. The widgets from Web App Builder and Experience Builder, my understanding is they have a different framework that wraps our widgets. So there should be some commonality there, but the specifics for how their widgets are authored, the base of their widgets is different. So I would recommend reaching out to the Ask Our Experts showcase channel for some answers.
Yep, reach out to them. They should be able to help you with that one. They're the experts with the Web Builder widgets. Okay, last one. Would you recommend using widgets to create complex forms with tabs, custom HTML, etc.?
I'd say depends on the use case. If you have a use case for where you want to reuse that same kind of complex form across different apps, I'd say, yeah, it would make sense to package that up in a widget that you can just share across your projects. If it's just for a one-off or just not really meant to be shared across different things, you could just write native JavaScript with HTML elements or something else if you want.
Yeah, that's a good point. Widgets is going to be reusable and focused things ideally. So if it's a complex form, maybe it shouldn't be a widget, but unless it's reused a bunch of places. But yeah, thanks, Franco. That's all the questions we have. If we didn't get to your question, we will reach out to you if you left your name and be able to answer it there. Otherwise, thank you guys for watching our presentation.
Thank you for watching. Have a good
Bye.
one.